Okay, so lastly, we can look at our replacement versus non-replacement. And this is necessary because soon we're moving into our tree diagrams and all those other probability methods. And you have to know whether these events occur with replacement or non-replacement. What do we mean by replacement? For instance, if I'm trying to work out the probability of me, I want to see if I have, of me seeing what's the probability of me drawing a red pen or red marker when I have two red markers and one blue marker. Okay, if I'm looking at for the probability and it's with replacement, that means if I'm doing more than one draw, let's say I'm drawing a marker two times. When I draw one marker, if it's with replacement, I then put back the marker in. Okay? If it's with no replacement, when I draw the marker, I don't put the marker back in. Okay? So let's look at replacement again. If it's with replacement, once I've drawn the marker, I put it back again. So the probability of me drawing a marker is 2 out of 3, right? Because I have two markers and the total number of possible outcomes are 3. What? 3 different markers. Okay? So if I have with replacement, when I draw the marker and I put it back, my probability of drawing a red marker is still 2 out of 3. But if it's without replacement or non-replacement, when I draw the marker, the probability of me now choosing a red marker is 1 out of 2. Okay? So my probability changes with replacement and without replacement. Okay? So let's look at the example that they gave us in the book. Okay, so we have Benny selects a sweet and he inspects the sweet and then replaces it. He then picks up a second sweet and inspects it. In this scenario, the probability that the first sweet that Benny will choose will be a toffee is 12 out of 20. Because he replaces his toffee, there will still 12 toffees left on the tray and a total of 20 sweets. This means that the probability that the second sweet that he chooses will be the toffee is still 12 out of 20. So it's the same thing with the markers, okay? Since it's with replacement, even though I've drawn a red marker, okay, I'm still replacing it, so my probability is still the same. It's still 2 out of 3. Now let's look at non-replacement. Benny selects a sweet and then eats the sweet. He then picks up a second sweet for inspection. In this scenario, the probability that the first sweet that Benny will choose will be a toffee is 12 out of 20. But now Benny doesn't replace the sweet. He eats it. This means that there are now only 11 toffees left on the tray out of the remaining 19 sweets. So it's now 11 out of 19. Okay. So now let's look at the worked example. A magician asks you to pick a card out of a standard deck of cards. What is the probability that you pick an ace of hearts? Okay, so now we're back at our standard deck of cards. We're looking at the probability of an ace of hearts. Okay, so we know how many ace of hearts do we have in the deck? 1. What are the total number of cards we have in the deck for us to pick from? 52. Okay, so my answer is 1 out of 52. The second question says, what is the probability that your friend standing next to you picks an ace out of the deck while you are still holding the ace of hearts? Okay, so since I'm still holding the ace of hearts and my friend next to me is now picking an ace out of the deck, okay, it's a scenario where it's non-replacement because I haven't put my ace back in the deck. Okay, so now I'm picking an ace with non-replacement. Okay, so since I haven't replaced my ace of hearts, how many aces are now left in the deck? So now we know that there are 3 aces, ace of diamonds, clubs, and spades left in the deck. Okay, and how many cards are left in the deck? 51, because 1 is with me. Okay, so we can simplify this to 1 over 17. The next question says, an ace out of the deck, or what is the probability that your friend standing next to you picks an ace out of the deck after you put the ace of hearts card back into the deck? Okay, so now this is the probability of an ace with replacement. Okay, so now I've connected the card, I put the card back in the deck. So how many aces are in the deck? There are 4 aces now because I put my ace of hearts back into the deck. What's the total number of cards in the deck? It's now 52 because I put my card back into the deck. So it's 4 out of 52, which can be simplified to 1 over 13.